Hey, so next example, we got a fraction going on here. So I got x divided by 2 minus 3 equals 1. And I'm going to bring this equation over here so that we can see both the illustration with algebra tiles at the same time that I'll show you what I'm doing just from a purely algebra perspective. Okay, so I got my teeter-totter set up here to keep the things balanced. I've got half of an x been cut in half here, and then minus 3, so the 3 red blocks, those are negatives. Now on the other side, 1 positive block. Okay, so if I'm trying to find x, then I want to get rid of the other numbers, like these 3 red blocks, right, that were subtracted right there. Yeah, I know also that I need to do that first because, whoops, SADMEG is my order of operations, and I need to subtract or add first. That's what shows up first. So the red blocks, if I want to get rid of them from the left side of my teeter-totter, I'm going to have to add, let me just grab these, blam, blam, blam. Oh, okay, it was a little bit less blamming than I was hoping for. Okay, sorry, I just stuck those there. So what I need to do is take 3 positives and I can drop them on top of these 3 negatives, and then they will cancel each other out. Whatever I do on one side of the teeter-totter equation, I need to do the same thing on the other side. Okay, so action shot going on right here. The 3 positives and the 3 negatives are going to cancel each other out. I'm just going to delete them. And then I had to add the 3 blues to the other side. Okay, from an algebra perspective, on my equation over here, I added 3, and I had to do the same thing on both sides of the equal sign. All right, so what that means is the x over 2 comes down to my next line, the equal sign comes down, and 1 plus 3 gives me 4. You know, all kinds of weird pen touches. I'm not being careful what's going on with my cursor here. It's kind of want this equation to not be red. Sorry about that. All right, so back to my illustration. I have half of an x on the one side, and that's balanced with 4 positive blocks. Well, I don't want half of an x tile. So what I need to do is double everything, right? If I double, then instead of half of an x, I'd have a whole x, and then whatever I get on the other side of the teeter-totter is what it'll take to balance it. So I'm just going to move those blue blocks down there, and then I'm going to spin this around so that my halves match up. I'll put the 2 halves together. All right, visual effects. I know my X looks terrible because it's not actually the 2 halves. It's the same half cloned. So 1x on one side of the teeter-totter balances 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what does that look like in the equation? Well, I have this division sign going on. I've got an x divided by 2 right there. And the opposite of division is multiplication. If I'm looking in SADMEG, division does happen next. It's my second level after doing adding or subtracting. So I'm going to multiply both sides of this equation times 2 and divide by 2 over here on the left will cancel one another, leaving me with just the x equals, oh, I don't like it when that happens. And then the 4 times 2 is 8. Oh, that is not a good looking 8. That is still not a good looking 8. We can't finish the problem until it's got a legible answer, right? That's some sort of rule. Okay, so algebra tiles hopefully are a little bit easier to visualize what is going on, why it is we need to do this stuff. But at the end of the day, we're going to be working with just equations.